Hi friends, welcome back to our YouTube channel. Today we have to discuss about Euler Graph or our Eulerian Graph in Discrete Mathematics course or our MFCS course. It is one of the most important concept. Now in this video we have to discuss whether the given graph is Eulerian graph or not. Before going to this problem, first of all we have to know about what is Euler graph or Eulerian graph. A graph G is said to be Euler graph or Eulerian graph. It must satisfy two conditions. First one is the given graph is a connected graph. That means we can take any two vertices in the given graph. That two vertices are connected by using path. Hence, we can say that the graph is said to be connected graph. Next, what is the second condition? A graph G must contains an Euler circuit. Okay, whenever these two conditions are satisfied, we can say that G is called as Euler graph or Eulerian graph. Now, what is Euler circuit? A graph G is said to contain an Euler circuit if and only if it satisfies two conditions. First one, a graph G contains a closed walk. Closed walk means in that walk, starting vertex and ending vertex should be the same. Second point, visiting every edge of the graph G exactly once. Okay, visiting each and every edge of the graph exactly once, but vertices may be repeated. Whenever these two conditions are satisfied, a graph G contains an Euler circuit. Whenever graph G contains an Euler circuit and it is also a connected graph, hence we can say that that type of graph can be called as Euler or Eulerian graph. Okay. Now, edges visiting exactly once. Edges visiting exactly once. Next, starting vertex and ending vertex should be the same. Third point, vertices may be repeated. Vertices may be repeated. Fourth point, it is a connected graph. So whenever these four conditions are satisfied by any graph, that graph can be called as Eulerian graph or a Euler graph. Now, check whether the following graph is Euler graph or a Eulerian graph or not. We are starting with any vertex. So first I am starting with V1 vertex. Then go to V2 vertex through the edge E1. Next, go to V3 vertices through E2 edge. Next, go to V4 vertex through E3 edge. Next, go to V5 vertex through edge E4. Next, go to V3 vertex through the edge E5. Next, go to V6 vertex through the edge E6. Next, go to V1 vertex through E7 edge. So, first condition, edges visiting exactly once. So, E1, E2, E3, E4, E5, E6, E7. So, this condition is satisfied. Every edge of the given graph visited exactly once. There is no repetition of any edge. Next, second point, starting and ending vertex should be the same. Here, starting vertex is V1 and ending vertex is V1. So, second point is also satisfied. Third point, vertices may be repeated. So, see this one, V1, V2, V3, V4, V5, V3. Here V3 is there, here V3 is there. So, vertices may be repeated. This condition is also satisfied. Next, it is a connected graph. We can take any two vertices. That two vertices are connected by using a path. For example, I am taking V1, V5. So, V1 to V6, V6 to V3, V3 to V5. So, these two vertices are connected by using this path. V1 to V6, V6 to V3, V3 to V5. Next, I am taking V6 and V4. Okay. So, V6 to V3, V3 to V4. These two vertices are connected by using this path. In the same way, I am taking V2 and V6. So, V2 to V3, V3 to V6. Okay, we are taking any two vertices. That two vertices are connected by using a path. Hence, we can say that that type of graph is called as a connected graph. So, four conditions are satisfied. Hence, we can say that the given graph is Euler graph or Eulerian graph. Next, we have to also another condition for checking whether the given graph is Euler graph or not. Okay. Every vertex of graph G contains even degree. So then G is called Euler graph. G is called Euler graph or Eulerian graph. Okay. So, what is the degree of vertex V1? So, vertex V1 is connected to two edges that are E1 and E7, so that vertex V1 degree is 2. What is the degree of vertex V2? V2 is incident on two edges E1 and E2, so that V2 degree is 2. Next, V6 degree is 2 because E7 and E6 are incident on vertex V6. Next, what is the degree of V3? So 1, 2, 3, 4. 4 edges are incident on vertex V3, so that vertex V3 degree is 4. What is the degree of vertex V5? E5 and E4 edges are incident on vertex V5, so that V5 vertex degree is 2. What is the degree of vertex V4? E3 and E4 edges are incident on vertex V4, so that degree of vertex V4 is 2. So V1 degree is 2, V6 degree is 2, V2 degree is 2, V3 degree is 4. Next, V4 degree is 2 and V5 degree is 2. Okay, so observe each and every vertex of given graph G. So all the vertices have even degree. Okay, so that we can say that every vertex of graph G contains even degree, then G is called as Euler graph. So therefore G is Euler graph. So this is another condition we have to satisfy to check whether the given graph is Euler graph or a Eulerian graph. Okay, so I hope all of you understanding this video. If you really understanding this video, please click on the like button and share this video to your friends and classmates. After subscribing my YouTube channel, click on the bell icon to get the future updates in my YouTube channel. Don't forget to subscribe my YouTube channel, Divvela Srinivasarao. Thank you one and all for watching this video.